Thank you, Alison, and good morning, everybody. Yes, so my name is Dr. Lauren Williams. I work for the Department of Forestry, Fisheries and the Environment. It's a South African national government department. And yeah, as Alison said, I'll be chairing this session, which focuses on data management. So by now, I'm sure that you are all familiar with all the housekeeping rules. They do remain the same. So please use the Q&A box to submit your questions, and the presenters will answer them live after the presentations. Right, so getting straight into it, our first presenter is Robin Payne. She is a PhD candidate at the University of the Western Cape, as well as a research assistant and data coordinator at the Zico South African Museum. She's currently involved in compiling a specimen occurrence database and species pages for South African sponges, and is the research coordinator of the IOE2 invertebrate specimens and data. While based at the DFFE as a student, Robin was involved in numerous sampling trips, including intertidal, scuba, and ship-based collections, while also participating and assisting in marine invertebrate taxonomy workshops. So with that introduction, take it away, Robin.
Hi, everyone. I'm Robin, and today my presentation will focus on reference collections, specifically the management and conservation of specimen collections. And I've been very fortunate enough to be based at the Zico South African Museum these last few months as a research assistant. And I'm also acting as the research coordinator of the IOE2 Benthic invertebrates, as well as their associated data. So your natural history collections really archive and provide access to biodiversity records by preserving biological, so for example, your plants and animals, paleontological, fossils, and geological, so mineral rock specimens, as well as their associated data. And this can really include things like botanical gardens, living collections, and natural history museums. So one such example is the Zico South African Museum, located in Cape Town. And this is really where the marine invertebrates collected during the IOE2 expeditions are currently being housed, and where many will actually remain indefinitely. So such institutions and the staff that work within them are really custodians or protectors of the collection, and they form part of a global network that provides fair access to the collections, as well as their associated data. So you can really get a lot of data from a single specimen. For example, morphology, photographs, sequences, parasites, toxins, isotopes, and things like your field observations. And so collection objects really have inherent value. So once lost or destroyed, they can never be replaced. So for example, if the specimen was collected in 1923 and it's been destroyed or lost, there's no way of going back and recollecting that specimen. And therefore your collections are really assets that are critical for scientific research. And they serve society now, but they also need to far into the future as new technologies develop. So to be useful for a range of applications today, while maximizing the shelf life and the condition for future research, the collections really need to be managed and conserved in a systematic and meticulous way, according to certain standards and procedures. So how do collection objects or specimens or collection lots make their way into things like a natural history collection or a museum? Collections really may be expanded through staff collecting trips, donation from scientists or other institutions, and from the public, which include private donations or private collections. Yeah, sorry. So just here are some images of collections done by DFFE, and many of these specimens are now being moved or currently housed at the Zico South African Museum. Specimens may also come through as exchanges, or they may be received temporarily on loan or for identification purposes. However, you really need certain requirements to be fulfilled before the institution actually agrees to take on or incorporate those specimens into their collection. So for example, your specimen should have been obtained legally and ethically, So you need to have the relevant permits in place. And the institution must have the resources to provide appropriate care, conservation, storage, and security for the specimens or the collection objects. Your institution must also have a focus, which kind of matches up with your collection. So this includes your taxonomic focus, the types of collections. So if they focus on fluid preserved or dry collections, and the geographic scope. So if the institution only houses specimens from South Africa or Africa or the North Atlantic, etc. And ignoring these kind of things can really lead to fragmentation and duplication at a national level. So you have kind of splits your resources. It makes difficult for staff to focus on numerous different collections, and you often actually end up with orphan collections. So as a side note, I've been trying to compile a specimen occurrence database for sponges in South Africa. And in doing so, I contacted many museums around South Africa or in South Africa. And a lot of the curators said, listen, we think we have sponges, but no one's really working on them. They haven't been digitized, so there's no electronic database. They're not actually even sure they exist or where they are. And so therefore they're actually inaccessible to researchers. Yeah, and then you also need a minimum amount of associated data with your specimens. So this is things like geographic location and things like coordinates, date of collection. Your other paperwork should also be supplied when you're donating the specimen. So things like permits, your field data, your field notes, your deck images, and this is really important because it links to the electronic database, and also for long-term archiving. So that's really important. And then finally, we only really allow collection objects that meet a certain standard or a certain condition that actually allow for research purposes. So you won't take on something that's like dried beyond being able to work on it, or maybe it's severely fragmented so you can't actually identify it properly, etc. So if these various conditions are met, an acquisition form will be signed. So they'll be both by the donor and the recipient institution. And the collection object or lot will actually be recorded in a handwritten register. And then each incoming consignment will actually receive a unique registration, acquisition, accession number that follows that consignment or lot of specimens throughout its whole kind of life cycle. So all of this information, so your images, permits, specimen information, databases, is actually recorded onto an electronic database. And for animals, we use Specify software. And I'm not going to really be going into the data management of this because it's mainly covered, I think, by the other presenters within the session. And however, it's just really important to remember that adequate safety or security systems are essential. And you really need to be doing regular database backups off-site. So really, before being incorporated into the main collection, all specimens must undergo treatment. So this could include being decontaminated or checked for pests. Obviously, you don't want a whole bunch of specimens to come in from one institution and bring mold or pests into your full entire collection. So all this could also just mean transference to an appropriate container, being labeled and allocated a unique number or catalog number. So every single specimen that comes in retains its original sample or specimen number that was recorded by the collector, but they also assigned a unique museum number, which is your catalog number. And this is really important that catalog numbers are not duplicated at the museum. And just for example, these are some of the IIO2 specimens. And as you can see, there are several issues that actually need correction. For example, risky labels. So, one drop of ethanol, that label's gone. Broken lids that can lead to evaporation, the use of plastic jars, and ethanol loss or discoloration. So there you can see the ethanol's nearly gone. There the ethanol's discolored, and that specimen's actually completely dry. Here are some of also IIO2 specimens that have undergone treatment. And you can see that they're actually stored in these beautiful glass jars with secure lids. Ethanol has been replaced or topped up. And it's really good practice to actually fill the ethanol to like about the neck or just above the neck. And that's really important for you to be able to monitor evaporation. but also provides enough space so that there's not undue pressure, which actually causes these lids to actually unscrew themselves. So specimens of this nature in the museum would usually be stored in about 70% ethanol, but we've actually stored these in about 96% ethanol, which is important for future DNA extraction and genetic work. So like I said, we keep the original label and we add a new catalog label. Your label should be easy to read and you should not obscure your specimen. So that's important. You don't want to be in the collection or the storeroom and you're trying to open a specimen just to see what's actually in it or what the label says, because that leads to deterioration and evaporation. And specimens should really be identified before being integrated into the main collection. So what we usually do is we start with rough sorting. So just eyeballing and putting them into like phylum level. You can also use your field notes from the collectors, that kind of thing. So you get them to phylum level. Then you can sort of do parataxonomy, where you sort them according to morphotypes. So these 3 shells look the same as those 3 shells, that kind of thing. And then you can actually get them identified by in-house taxonomists, so taxonomists that work at the museum. However, there's a huge taxonomic impediment, not only in South Africa, but worldwide. So often we don't actually have the expertise to identify our specimens. And so they may have to be sent either a small sample or maybe just a collection object image to other taxonomists to try and get the stuff or the specimens identified. So while processing, it's often best to carry out imaging as well. And that's just because you're working on the samples, you've got them there in the lab anyway. Imaging is really important as it can serve as a permanent record of the specimen, including information about its condition. So you can see if it's fragmented or broken, or there's 4 specimens in a jar, that kind of thing, as well as information provided on the label. So even if this specimen is destroyed or lost in the future, you still have a permanent record of it. The purposes of your imaging really influences your image resolution and the number of views that you'll take or views that will be imaged. And you've got to remember that files can become very large and the process can become time consuming. So it might be best to only do very high res images for your type material, which are those specimens on which new species have been described. So just some things to remember. So this is just an example schematic or diagram. So that's like your lab desk. It's really important that your background and your specimen orientation are consistent. It's best to use like a black or white background. Your lighting should be consistent with no excessive reflection, which is can be quite difficult with wet specimens that have been in fluid and are wet. The specimen should take up as much of the frame as possible. You should have your original label as well as your catalog label. These should both be included and they should be readable. So your catalog number will also usually include things like location, collection data, etc. These labels should be made of a certain material. So they usually use thermal printed labels. And if you're writing on them, we use archival quality pens so that your writing doesn't smudge or like disintegrate over time in the ethanol. It's also important to include a scale bar with your institutional logo and your name, as well as a color chart. And there should also be information regarding the copyright or the licensing. So it's really best to capture high image resolution images. So for like example of a minimum of about 300 dpi. This is important for publication. It's often a requirement in your publications. And so it's better to do it in the beginning rather than to have to go back and re-image 500 specimens. And then you can always edit your images on software like Photoshop, and there's also a lot of free software is available online. And then when you're renaming this image, it's best to name it according to the catalog number. And you usually have 1 folder per collection. So you don't want a very complex system with a hierarchical 500 different folders, which makes things difficult to find. So when processing or treating specimens that have not yet been incorporated into your main collection, it's not advisable to store them in the lab. So they can be stored within the collection room, but you usually keep them on separate shelving from the main collection and you work on them in batches. So here's my lovely lab mate, Mutombi. She's also working on the IIOE2 specimens, And here she is just sorting specimens, and this is our lab. So you can see we don't have many, and we just try to work on them in batches. And this is mainly to prevent deterioration. So although we can expect deterioration over time and with the necessary handling of the collection, it really needs to be minimized. So we have 10 most common agents of deterioration, and these include things like physical force. So that's dropping a specimen, even pushing a specimen on a trolley, or vibrations when you open a cupboard or a tray can actually lead to the lids unscrewing. Criminals, so that could be someone trying to get, I don't know, computers or laptops, and they damage collections in the process, or it could be someone trying to steal type material because it's cool, like coelacanth baby, for example. Things like fire and water. With water usually comes mold, and also it's really good to keep your specimens kind of elevated. So if you do get flooding, they're not under the water. Pests, that's like cockroaches and fish moths, and you usually handle those with fumigation. Your pollutants are chemicals and dust, so it's best to actually not have windows in your collection at all, your collection storeroom, sorry. You don't want dust or also light and UV coming through. You can have incorrect temperatures, incorrect relative humidity, as well as dissociation. So this is also known as custodial neglect, and that really focuses on your data loss, you've misplaced collection objects, or sample mixing. So you haven't really followed proper procedures and you're kind of making a mess up. And this is why it's really important that specimens are actually donated to institutions that have the necessary resources. So the right cabinets, the right staff, the right training. So as an institution, you really want to provide multiple layers of protection. So all your material should be stored in the same location unless different conditions are required. For example, fluid preserved collection versus a dry collection. And this is just a diagram explaining the different kind of, the more layers you add, the more protection you get. So that could be like your outer building, your room, so that's like the store, the collection store, furniture, compactors, cabinets, your container or housing object, that could be little boxes or jars, and you may even further package or wrap them. So your storage area must be exclusively for storing collections and must be sealed off as far as possible. So like I said, you try not have windows you open, or you actually try not have windows at all. You try to keep the area dim. You don't eat or drink in the area to avoid pests. And then also what's important is all the staff that work at the museum should understand the inherent value of the collection. So whether you're a curator, whether you're a visitor, whether you just whether you cleaning, you really need to understand the inherent value of the collection. So archival and conservation grade material must be used in the study, storage, and display of the collections. So this includes things like metal cabinets and fireproof materials. So for example, the Iziko Museum has these giant compactors, and they can hold the weight of a fluid collection, but they're also mobile, so which is really important for space constraints. And then again, you can see they protect from like light and dust. When specimens are too big to fit in jars, we usually put them in fiberglass or stainless steel containers. So the storage area must really be housed in a pest-free environment that is climatically controlled. You really want to avoid fluctuations in temperature and humidity. So humidity, you usually try to keep it about 50% with slight fluctuations, temperature at 16 to 22 degrees Celsius. And data loggers can be really important for this. So you can see sort of the temperature or the relative humidity of your collection over time, maybe the air conditioning is not working, etc. So your most important factor in arranging the collection is that it should be usable. So with staff needing to be able to find collection objects very quickly. So for example, you might have a researcher coming from Tanzania or the Comores or America, and they really are trying to look at a type specimen. So maybe they're trying to compare their species with a type specimen to see if they have a new species, and they're coming to your collection and they say, this is the catalog number. And you're like, oh, I don't know where it is. There's 5,000 specimens. So your collection should really be arranged systematically at the higher taxonomic levels, so like your phylum, and then alphabetically by order and family. So then they can actually say, this is the catalog number. You can go straight onto your electronic database or specify, and it'll say it's in this room on this shelf. So the location of your specimen in the collection must be included in the database, which is very important, and its movement must be documented. So if you're working on it, you should document that. If it's being loaned out, you should document that. And like I said as well, it's about having a coding and numbering system for the collection, storeroom, cabinets, compactors, etc. So you can say it's in the storeroom and the third compactor on the fourth shelf. So nevertheless, no matter the amount of planning that you do, collections can also be at risk from disasters, natural or otherwise. So fire is probably the highest risk, especially to natural science collections. That's obviously due to the ethanol or the storage medium. And this is really evidenced in the 2018 fire that destroyed millions of collection objects housed in the National Museum of Brazil. And even earlier this year, the University of Cape Town in South Africa also experienced devastating loss, with buildings housing special collections that were gutted by a fire. Other hazards could include things like water damage, power and water cuts, hazardous materials, and theft. So you really need to have regular risk assessments and monitoring mitigation plans in place. So things like a spill kit for if you spilled ethanol everywhere, that kind of thing. So this is another reason why your collection inventory, complete with location, should really be up to date. So you'll have a list of prioritized collections, for example, your type materials, or your loans from other institutions. So if you know that there was a fire in room 3, you know what specimens you've lost that have been destroyed, or if it's a day after fire or the fire's just started, you can run in and say you'll prioritize your most important collections, such as your holotypes. And then you really need to have a salvage plan for disasters. So it's a day after the fire, and you really need to act quickly to maximize recovery of your collection. So you need to have a treatment plan, a triage area where you're taking the specimens, and obviously how you treat them. Should you put them in a freezer while you decide to prevent mold, things like that. So your specimen data are used in a wide range of research and practical applications. So this could be things like species modeling, in conservation, etc. And institutions are required to actually provide access to the collections for research purposes to scientists both in and outside of the institution. And it's really important to remember that increased access to the collection or to data means increased use of that data, and therefore increased value and appreciation. So people will really value and appreciate that the kind of role that museums play in society. So you can really get different types of access, such as the loan of the collection object. So this is already difficult in COVID times, but also not really recommended because with shipping can become damaged and specimens can become lost. So often we'll rather send a digital image of the collection object. If possible, obviously multiple views with diagnostic features for taxonomic purposes. You can also physically visit the collection and examine the material. You may also get provision of subsamples or tissue samples, things like DNA. This request might actually be denied depending on the size of the specimen, the number of specimens of that species, if it's a sensitive species, if it's an unusual species, things like that, because obviously you want to preserve that specimen or those specimens for future research as well, so you don't want to completely destroy them. Again, your digital images of your collection objects and collection object data. So that could be the curator or the data manager sending you the electronic database from Specify on your required taxon or taxa, or you could actually just download data from GBIF, which is the Global Biodiversity Information Facility. So my takeaway message would probably be to remember that a natural history collection may comprise millions of specimens collected over hundreds of years, and it really has to survive numerous career changes. So consistency and documentation is essential. And again, it all starts with you. So the researcher, the student, the collector, you must really be meticulous and mindful with your specimens and the associated data. to know where they're stored, monitor their condition, and have a post-collection protocol in place. So often, we plan our field trips, we plan our where we're staying, our accommodation, our sampling design, but we don't think about what's going to happen to the specimens after we've collected them. Are we going to deposit them? At what institution are we depositing them? That kind of thing. And apart from them having inherent value, there is also ethics to consider. So, to be blunt, an animal or plant had to actually die for that research. So it's best not to be wasteful, and really make sure that it can be accessible and stored in a condition useful for future work. So this could also instigate things like collaboration and reduce the cost of field trips for other researchers that can work on these specimens already collected and stored at the museum. Not everyone has access or funding to do huge field trips or go to sea. And so here you actually have an opportunity to work on specimens that have been collected by other people. And then even from a monetary perspective, if you think of the cost of field work and going to sea and doing, dredges at 3 a.m. in the morning, the planning, the manpower, coming back, processing specimens, and then you just don't do it properly and that specimen is basically redundant, it can't actually be used. So if you think of it in that way, and if you were to divide the cost of actually going and collecting those 50 specimens, how much that specimen is actually worth. I just want to say most of this work, or most of this that I've covered in this presentation is actually found in this manual. I think it is found free online, but I will try to put it into the literature folder as well. But there's also a lot of, if you just look online, there's a lot of different manuals that you can use as a reference, and a lot of YouTube channels that actually might be of interest as well. And I'd just like to take the opportunity to thank you for listening to my presentation, as well as to the DFFE for allowing me to participate both in this workshop and in one of the expeditions. And then as well, the Ezeco South African Museum. They've been very accommodating and friendly and have taught me a lot over the few months that I've actually been there so far. So thank you.
Great, thank you so much, Robin. Wow. So all I can say is that was really, really interesting. We often associate data with spreadsheets rather than specimens. So it's definitely a different type of data than what I'm used to working with. But you did mention a lot of the familiar standards and data principles that we all follow. So that for me was quite interesting, quite exciting. So I've got some questions. First, let me first have a look. I don't see anything in the Q&A, so I'm going to go ahead with mine. Your electronic database, does that database communicate with any other institutions, similar institutions that also house collections, so that you may be able to see what others have? And with that, how do you sort of prevent this duplication of effort when different institutes are collecting data?
Thanks, Lauren. I can't really speak too much about that just because I've only been at the museum not that long, so I haven't had much experience, to be honest, with Specify. I think maybe some of the other presenters that are coming on after me can talk maybe to that. I do know, I think Specify is used by most of the natural history collection kind of staff within South Africa. I'm not sure if it's linked. I think maybe that's just because to keep your data quality, in the right way. So no one can really edit it or anything like that. So as far as I know, all you can really do is if you want to get data from, for example, the Ezeco South African Museum, you would contact the curator there or the data manager there, and then they might be able to give you access to that data. But I know as well, it is published. They're very good with publishing on GBIF. So that's what I mentioned earlier. So they do actually go through the collections and have very good quality control, and then they publish that data. So you can have access to that data and you can actually download it freely off GBIF as well. Yeah, but hopefully some of the other presenters can maybe talk to that. Sorry.
No problem. So we do have some questions coming in through the Q&A box. What percentage of ethanol must be used to store samples?
Cool. Okay, so obviously, I think anything less than 50% is really bad. So obviously, the higher percentage you can get to, the better. So often we dilute our ethanol. That's why we get to about 70%, because you got to remember you're dealing with a huge collection, huge amounts of ethanol. But then obviously for things like genetics, you want to store your specimens in about 96% ethanol. So obviously the higher the better. Obviously that's, it depends on cost of ethanol, which is very expensive. So that's why you often dilute it. But yeah, for genetics and things like that, also for future research, you think, I touched on that with like future technology. So it sounds stupid to us now living in this present age, but if you think, 10, 20, 30 years ago, how quickly technology has changed, we just don't know in the future. I think so, for example, I think in the past they used a lot of formalin, and so we kind of realized that ethanol was better and preserved our specimens better. And so it's just thinking of those kind of changes. So really managing your collection in a way that if something happens in the future, you can actually still use those earlier specimens.
Great. And you just mentioned formalin now. So we've got another question up in the Q&A. There are some organisms which are advisable to fix with formalin first. However, formalin is not advisable if you need to do DNA analysis. So how do you balance that?
Oof, it's difficult. I think that really depends on the project that you're focusing on. So obviously, as a traditional kind of baby taxonomist, as I would call myself, I'm all about morphology and things like that. But I do recognize that we're moving towards a future where you really want to do traditional taxonomy with your genetics. So it's always better, I think, to keep that in mind, because maybe you're not even focusing on looking like resolving a genus or a family. Maybe you're just doing traditional modern taxonomy based on morphology. But someone in the future might want to come to the museum and work on those specimens 50 years from now. But of course, as well, it really depends on your question. So if you have more of a genetic question, I think, if I'm not mistaken, I think you preserve it in formalin so it stops deterioration, or I don't really have much experience with formalin, but yeah, so I think that really depends on your personal research question. Also, formalin is also very, it's a health and safety hazard. And you can just to store it and for people to work on it is also not advisable really as well. Yeah.
Great, thanks so much. I've got another question for you from me. So you mentioned that the images are available for dissemination. So how is it that people will go about requesting them? Is there a website, an open website or so that they can access and request?
Yeah, so if you see, so some of the museums overseas, for example, the MNHM, those kind of museums, they often publish their photos online. So that's why I mentioned like the copyright image. And I think a lot of the times, because a museum is about having free access, for everyone to the collection and to the data and to the images as well, they often publish their stuff online. So I actually use some of those images freely available, Unfortunately, right now, I think in South Africa, maybe I'm being too kind of generalistic, but we just don't have the funding as well to get the images, to image the vast, huge collection, and then to get that all to standard where we can publish that online. So that might be a future, consideration. If anyone's interested in, sorry, just to say, like if you want to come visit the collection or you want to work on the specimens or the images or that is we can do that 100%. And I mentioned the images specifically because we don't really want to send specimens away now just because of, or the IIOE2 specimens specifically, just because of COVID, obviously. And then your especially if you're dealing with specimens of the transport to different countries and things like that, that's how your specimens get damaged or lost. So we do send images out now. So anyone that's really interested can just contact me and we can like make a plan. That's how we're doing it kind of right now. But hopefully in the future as well, once we work on these samples and we maybe maybe do like a preliminary guide or something like that as well, then those images will be publishable in there as well.
Okay, thank you. Another one in the Q&A, is there a time frame for when sample ethanol must be replaced? So like once a year, once every 2 years?
Yes. So what we do, I think at the museum, again, I might be being able to be corrected, but I know where we monitor again, it's a huge collection. So you usually try to change it, I think, every 4 or 5 years minimum, like maximum. You don't go over that time period. But again, it's monitoring the collection. So when you're walking in the storeroom or the collection rooms, you'll see if ethanol has started to evaporate. And that's really bad because it can actually change your ethanol concentration, so your specimen's not being preserved properly. So then you've got to really monitor. If it's below 10% or something, you can just top it up with ethanol. But if it goes further than that, you actually have to use a specific equipment to check the actual ethanol concentration and fix that. Again, if people are working on the collection, so again, it's a huge collection. If someone's coming over and they're working on crabs, for example, they might say, okay, they pulled out 50 specimens and they see half of them are evaporated or they need some topping up. So it's like a piecemeal basis, but then there is kind of, like a larger scale topping up of the whole collection that does get carried out. Yeah.
Okay. So because there are no more questions in the Q&A, I've got my final question. Final question from me. So your process obviously to me seems quite manual because you're dealing with specimens, which is something I do not do at all. Is there a quality control process that you utilize when you are busy doing your cataloging? Like, does someone check that the specimens labeled correctly?
Yes, no, definitely. So there's usually we have a manager. Albie was the manager, but I think he's just left. So he'll be his presentation is after the break, I think. But yeah, so you do have someone. Not everyone has access to like the actual data and specify things like that within the department. You have like a main person that has all the catalog numbers, so you don't get duplication and things like that. And even with the data, we'll have that manager as well check. So if I'm doing a spreadsheet of all the IIO2 stuff or the specimens, they will also check through that and make sure it follows the proper Darwin core standards and things like that before it gets published. Yeah. So we do follow and it's very strict. So obviously we got to be very careful to assign only one catalog number per specimen and things like that. Otherwise in the future, it just causes absolute chaos. So yeah, it's quite strictly controlled. And then of course, I think as well on your specified database, if you put a catalog number and you cannot physically duplicate it. So if you try and make another specimen with that same catalog number, I think it'll come up as like an error or something like that. So you actually, it prevents it from happening.
Great. Well, I'm out of questions. I'm checking the Q&A. I think the participants are also out of questions. So the only thing standing between you guys and lunch is me. Robin, thank you so much for a wonderful presentation and for taking those questions. I found it really, really interesting. I definitely learned something today. And yeah, I want to wish you all the best with your studies as well. So thank you so much.
Thank you very much.
Great. So we are a little bit ahead of schedule, but we will break for lunch now, and we will be back at 1:30. So we'll see you all back here soon. Thank you so much. Okay, welcome back, everybody. I hope you had a good lunch. So in our last session, still continuing on the data management theme, we have a presentation from Albie Bosman, who was recently employed as the collections manager in the marine biodiversity collections at the Zico South Africa Museum. Along with his duties as the collections manager, he acted as the data manager for all the natural history at the museum. He has a keen interest in the bioinformatics and data management as a whole, and has presented numerous data management courses, most notably the CKI's data management course. So with that, I welcome Alpi's presentation.
Good day, everyone. Sorry, let me just do this. Right, good day, everyone, and welcome to my talk/lesson on data management. My name is Albi Bosman, and I used to be the collections manager for the marine biodiversity collections at the ZICO Museums of South Africa, where I also took it upon myself to take on the data management role. I am no longer at ZICO, as my family and I took up an opportunity in the land down under, as you can see here. Now, a bit of a disclaimer. I found it extremely difficult to set up a talk that was meant to be delivered as a workshop without having people to present to or even have a live audience to interact with via Zoom. So if it gets a bit stale or long-winded, I apologize in advance. Data management, and more so data cleaning, is certainly much more interesting when one has a physical data set to work with. So bear with me. So this talk will deal with the theory, and I will show you some tools and some examples, but please feel free to contact me if you have any queries. So with that, let's jump straight into it. So what is data management? Very broadly, it is essentially the process of controlling information. And why is this important? It provides easier access to data for easier analysis, reproducibility of research, new opportunities for integrating data between research projects, improved data quality, and probably most importantly, it supports the published results of your work. The problem we face is that there is a massive flood of data is being generated in massive quantities. Just the other day, our resident entomologist recorded collecting nearly 100,000 specimens in 1 month. Improvements in technology enable higher precision and coverage in data acquisition and makes higher capacity systems store and migrate more data, which leads to increasing the importance of managing, integrating, and reusing the data. What complicates matters even more in the biodiversity sector is that data are stored on various media in different formats, non-standardized data formats, etc., are used. So let's quickly look at it from a researcher point of view. Manage your data for yourself. If nothing else, it is key to keeping yourself organized. You should be able to find your files, for example, your data inputs, your analytical scripts, your outputs at various stages of the analytic process, etc., It helps you track your science processes for reproducibility. You should be able to match up your outputs with exact inputs and transformations that produce them. It gives you better control of versions of data, so easily identify versions that can be periodically purged if you want. And of course, quality control your data more efficiently. Again, I iterate, manage your data for yourself. Make backups to avoid data loss. I've had to restore our database countless times, and without a backup, it would have been impossible. I suggest setting up an automatic backup protocol, which can be done through scripting. So, format your data for reuse by yourself or others. Be prepared. So document your data for your own recollection and reuse, again by yourself or others. Prepare it to share it. Gain credibility and recognition for your science efforts. Why data management from a more holistic view? Data is a valuable asset. You all know that it is expensive and time-consuming to collect. Data should be managed to maximize the effective use and value of data and information assets. Continually improve the quality, including data accuracy, integrity, integration, timelines of data capture and presentation, relevance and usefulness. And ensure appropriate use of the data information. It facilitates data sharing, as mentioned before. It ensures sustainability and accessibility and long-term for reuse in science. The data life cycle. Here we have a schematic of the data life cycle. Basically, a data life cycle illustrates stages through which well-managed data passes from the inception of a research project, right here, to its conclusion. In the reality of science research, the stages do not always follow a continuous circle, but we will try our very best. So, enough about me lecturing you on things you already know and doing on a daily basis, right? At the museum, we deal largely with foundational biodiversity data. It is for this reason that we use the Darwin Core Standard. Some of you might know it. But broadly speaking, this standard is a body of standard practices to facilitate biodiversity data sharing. And more specifically, it is a list of common biodiversity data terms. I think Willem Kutzer will mention the Darwin Core at his talk again later. So what I mean by occurrence records, essentially it comes down to the what, the when, the where. What species was collected, when was it collected, and where was it collected. Those three pieces of information is key in the makeup of an occurrence record. So, thus far, we've briefly looked at the Darwin Core Standard. We discussed foundational biodiversity information, data, and we looked at why data management is important. So what happens once the data has been captured? Before we start there, let's look at some uses of foundational biodiversity data. And I'm not going to spend too much time on this because the community here already uses the data for all sorts of wonderful and innovative things. But essentially, it includes taxonomic studies, biogeographic studies, species modeling, life histories and phenologies, conservation planning, studies of threatened and migratory species, bioprospecting, etc., etc., etc. Now, if you are not familiar with the work of Arthur Chapman and his colleagues, I highly recommend you look into it. He is one of the most prolific figures in the world of biodiversity data. You can get more detailed info by looking at these documents produced by Arthur Chapman. So here we have an example of the benefits of sharing data. So if you look at the records of the Paris Museum, you'll see that there's not a lot of them. And this is bird data, Mexican bird data. The British Museum has some records. The Field Museum has some records. Kansas University Museum have some records. And if you put all of those records together, you can get a much, much better picture of what is happening with the Mexican birds. It'll allow you to answer much bigger scientific questions than just having data such as the British Museums or the Field Museums. So we can all see the benefit of sharing data, right? So data quality is more than just accuracy, all right? Quality is related to the data's usage, its timeliness, relevance, and accuracy, or more commonly referred to as fit for use. So what is meant by fit for use? Here I have a silly example of the use of the concept of fit for use. The collection of a particular species marked A has an accuracy of 50 kilometers, denoted by the little circle here. If one is preparing a list of Tasmanian species and want to know if that species occurs in Tasmania, then the record is suitable to answer that question. Thus, the collection is fit for use and can therefore be regarded as high quality for that purpose. On the other hand, if one wants to know if the species occurs in the Tasmanian World Heritage Area or not, then one cannot answer that question from the record. It may or it may not. The data are thus not fit for that use and are thus of low quality for that purpose. The latitude and longitude values in a database may be very precise and give the appearance of having a high accuracy, and this can be misleading to the user of the record. Does not also include a value of the accuracy. Sorry, my slides right here. So as a starting point, it is important to understand where accuracy of data is lost. And I'm sure all of you know this already. At the time of collection, during digitization, during documentation, during storage and archiving, during analysis and manipulation, at the time of presentation, and through the use to which they are put. Some of this can be mitigated by adopting international standards such as the Darwin Core Data Standard and aligning data collection and processing with international best practices. So here we have a quality information chain. As we get further along the chain, it becomes more expensive to fix errors, as you can see on the chain here. One way of mitigating data quality loss is to assign responsibility for the quality of the data to those who create them. If this is not possible, assign responsibility as close to data creation as possible. So basically, work as accurate as possible at the point of collection. This will save you quite a lot of resources in the future. One also needs to assign responsibility for the quality of the data to those who create them. If this is not possible, assign responsibility as close to the data creation as possible. This will help you tremendously in your project going forward. In taxonomic and nomenclature data, you typically get 3 types of errors. These include taxonomic, georeferencing errors, and keystroking errors. Sorry, when I say taxonomic and nomenclature data, I mean foundational biodiversity data. Names are often the first point of entry to biodiversity databases. What I mean by that is when we get a query at the museum, we generally get a query that says something that goes something along the lines of, can you give me all the records for species X? Hence me saying the name is generally the entry for most biodiversity databases. If you're not careful, things can snowball from here. Here are some examples of things to look out for. Wrong identification, wrong format, spelling errors, missing values, incorrect values, non-atomic values, domain schizophrenia, and duplicates. Here we see a real-world example. So in our database at Ezeco, we have many more species names in our database than the number of known species in South Africa. In part, this may be resultant of the taxonomic data error variables listed in the previous slide. So if you just look at this figure, you can see that in red, it's the known fauna. So for invertebrates, marine invertebrates, there's 9,162 known species. And in our holdings, we have 13,582. So either we're sitting on a gold mine of new species identification, or there's some error in the database. And the same trend can be seen with fishes. So in order to understand the georeferencing errors, one first needs to understand a couple of terms. So bear with me. This is not the most interesting topic. So what is a georeference? The code that records a position on the surface of the Earth according to a spatial reference system, aka coordinates. Then what is georeferencing is basically the process of assigning geographic coordinates to a record, or simply putting a dot on the map. And what is retrospective georeferencing? This is something that we mostly do at the museum because most of our records are pretty old. So we have to retrospectively go back and georeference them. So like I just explained, retrospective georeferencing is assigning coordinates to legacy data quality generally not very good. So what is a geodetic datum? Combination of a spheroid representing the Earth and the position of the spheroid along the center of the Earth. It gives orientation and origin to lat long values, essentially. So here are some things to look out for with regards to georeferencing. So the most common mistake is obviously the spelling error in locality, or when digitizers transcribe from labels to your Excel spreadsheet flat file, because handwriting back in the day wasn't that great. The lat long gets inverted, so basically they get swapped around. The zero value for on or both of lat and long, you can see this line running here with zero values. There's no recorded datum. The wrong choice of the SRS or false sense of precision is given. So this is something that one needs to look out for when converting coordinates from degrees, minutes, seconds to decimal degrees. One needs to be very careful that you don't add false precision to the end. So I generally like to, when I'm dealing with retrospective or historic data, I generally like to only go to 2 decimal points when I convert. So the third and final common error is keystroking errors. Essentially, it is spelling mistakes or accidentally pressing the wrong key on the keyboard during digitization. And most digitization occurs from handwritten labels at the museums and can sometimes be quite difficult to decipher, which leads to errors. This is actually quite a nice label here. It's quite legible, to be honest. Some of them gets quite bad. So I'm going to run through some of these tools that will aid in data cleaning and data quality and that sort of thing. So the next section of my talk is normally where we would all get some time to sit down and practically use the aforementioned tools to clean some of your data. But given the circumstances, I will just run through a typical example of what I normally do when I get a file to clean, in inverted commas. As with everything in life, theory always sounds amazing, but almost never translates directly to practice. So you need to integrate the tools and internationally best practices into your own workflow so that it works for you. By no means are these the only tools or workflow one can use to get the desired outcome, but these I found have worked for me in the museum setting. As many of you know, and as mentioned before, data comes from a lot of sources. I will be going through the example of what I personally see the most of at the museum, and this would be digitizing backlog. These are the hundreds of thousands of specimens still waiting to be integrated into their forever home. So this is typically what I would do with a backlog digitized flat file in the museum. So you have specimens with labels that contain the what, the where, and the when. This gets digitized to an Excel flat file. And then from here, it gets subjected to a quality control check. So I start with Open Refine. I'll show you that now. From there, it goes through worms. Everybody, I'm sure, is familiar with the World Registry of Marine Species. And then finally, it goes through a process of georeferencing at the end before it gets committed to our specified collections management database. Right. Sorry, let me just get this slide going. It seems a bit slow, the PC. Here we go. So as mentioned, these are typical of the backlogs. You see these hundreds of jars with specimens in it and labels in it that needs to be digitized, augmented, and then fixed, cleaned, if you will, and then committed and integrated into the collections. So here is just an example of the what, the when, and the where. And as you can see, there's quite a number of other other pieces of information that also gets digitized alongside this. But the most important bits for an occurrence records in the museum is the what, the when, and the where. So, like I mentioned, I start with OpenRefine. You can install it from their website, download and install it. So once you have installed OpenRefine, launch it. And then to create a project, click on the Create Project button, right? Then click on Choose Files, click Next, and then what happens, so once you've chosen a file, browse chosen a file, and you click Next, a data configuration log will pop up. Here you can see a preview of your data, and you can make any changes to it if necessary. This is also the part where you can rename your project or add tags to it for future references. The layout is quite simple. Every column, so after that, you then say create project, and then boom. The layout is quite simple. Every column has a drop down arrow at the top, which opens up the menu of the various changes that can be applied to the column. And then on the left-hand side, there are two sections, one facet filters and undo and redo. Faceting is a feature that allows the user to group the values that are in the column and enables the user to filter through and edit the values across various cells simultaneously. The undo redo function is miles better than Excel undo. It works as a time machine basically for implemented changes. Whenever you make a change to your data, it logs it. And whenever you find it necessary to go back to the data before you made a change, you can simply select it from this log menu. So OpenRefine is an amazing tool. I use it specifically to check for inconsistencies in the data through applying various facets to the data set, from changing data formats to fixing keystroking errors, etc. So once you're done with this, you can export your data to a range of formats just by clicking on export here and choosing the option that you desire. Okay, export. Right. So the next step that I take after fixing any inconsistencies in the data would be to validate the taxonomic names. So here's a big disclaimer. I'm not a taxonomist. So services such as the World Registry of Marine Species, an amazing tool, but should not be taken as the gospel. So if you're not familiar with a taxon, then it can be very dangerous for you to make decisions on whether a name is valid or not, based on what gets returned from the service. So again, big disclaimer, be careful about firstly what you put in, and secondly what you get out of it. Like I said, you shouldn't take this as the gospel. Although it's a very useful tool and the quality is amazing, it might not include all the latest papers for a certain taxon, etc., etc. So I'm just going to run through this quickly. So this is essentially what it looks like, the home screen. From here, you can do all sorts of taxa search. You can search the literature. You can do a specimen search, distribution search. But the big tool that I like about this is under tools here. So if you click on that, you'll see there's a thing called Web Match Taxa. What this allows you to do is it allows you to take your Excel spreadsheet, you choose it here, you choose the various options that you want and the fields that you want to return it. And then what it does, it matches up your names with the names in this database. And then it gives you the valid names and then every other option that you've picked here, which is quite useful if you want to batch process the validation of taxonomic names. It can also tell you if there's fuzzy matches, for example, that you didn't pick up the spelling mistakes in the previous step, etc., etc. And what you'll end up with is an Excel spreadsheet with all of those fields populated for you. So what it'll do, it won't delete your old data. It will just create new columns at the end of your spreadsheet. The final step in my workflow is to add coordinates and uncertainty to each record. For this, I use two tools. Firstly, the georeferencing calculator. So this tool enables you to calculate the uncertainty for a given locality, whether it has coordinates already or not. Right, so it's pretty straightforward, simple thing. I wish we could go through a practical example of all of this, but it is what it is, and we are where we are at this stage. So there's also a very nice document that goes with it, and I'll link to it now in the next couple of slides. So here's the georeference. So this is where the landing page for it is. And then when you click on these georeferencing quick reference guide, so what it'll do is basically it takes you through the steps of it asks you what type of data you have. So whether you just have a locality string or you have a locality string and a Latin long, etc. And then it tells you what options to choose, and then it gives you an answer and how to interpret that answer. So there's just an example of the quick guide. So here you can see your locality type is basically just a named place. So you just have a locality string. You select the calculation type as error only. Locality types named place, coordinates, tells you what to do with them, and it tells you what to do with the extent. It's very useful, a very, very straightforward guide to use. So the next tool is geolocate. What makes this tool so nice is that it has a batch processing function, and I'll show that to you now. But again, a big disclaimer, geolocate works best for US localities because it was developed there, but it still gives very good results for the rest of the world. I've been using it for quite a long time. But again, just like with worms, always go back and do a screening of what it is that what it spat out for you. So what you want to do is you want to go on web applications, and then very importantly so the standard client is where you can just do once-off georeferences if you want. And then the batch file-based client is based on a CSV file, right? So before you click on batch file-based client, you'll see that there's a link here called file formatting instructions. Now, it's very important that you follow those instructions, otherwise the batch processing will not work. So this is what you need to do. You need to format your Excel CSV file to add these 10 columns. So you can then, after the 10th column, you can add any other columns that you want. So you don't have to delete your data or whatever. Just so that when you have your locality text string, you must put it in here. Any lats longs that you have, any country, state, county information you have, you must populate it with these columns. Now, what I normally do is I copy those and populate it in here. I don't delete my other data that's sitting at the end there. And then what you'll do is once you've formatted your file and you've loaded the web application, you'll select a file, right? And this error pops up all the time because Windows. That's all I'm going to say about that. The quick workaround for this is, and believe me, I've tried to do it using the list operator and your regional settings and all those sorts of things. It doesn't work. So the quick workaround for this is you simply open your Excel CSV file in Notepad, and then you replace all the semicolons with commas, and then save it, and then you can open it up in here. Right, and then you get a file like this. Now, if you want to do a single off georeference, you can highlight a record, click georeference, right? Or if you want to do the whole page, so every record listed here, you can just click page georeference, and then it will find all of these lat longs, precision errors, and that sort of thing. Once this is done, you can export it into a new Excel CSV. Sorry, so this was an example I wanted to do with you, but seeing as though it's not live, I'm going to skip through it. Right. Sure. So, take home messages. Sorry, let me just do this. So we collect more and more data every year, as mentioned before. The cost of not doing data management can be extremely high. So one needs to be cognizant of best practices and tools associated with the data lifecycle to manage your data well. There are many benefits associated with the act of managing data, including the ability to find, access, understand, integrate, and reuse your data. If data are well organized, documented, standardized, preserved, accessible, verified as to accuracy and validity, the result is high quality data, easy to share and reuse in science, citation and credibility to the researcher, and of course, cost savings to science, which is probably the most important one here. And those are the list of references. Like I said, please feel free to contact me if you have any questions or concerns or suggestions. Yeah, thank you for listening to my talk.
Great, thanks so much for that presentation. So Albie is unfortunately unable to join us, but Willem Kutzer, who's actually our next presenter, has graciously volunteered to assist with the Q&A. And I see that we already do have some questions up here. So thank you, Willem. You are unmuted now, great. Okay, so question number one. In large projects with no dedicated data manager, multiple people might be using the same files. What is a good way to streamline that process so that you avoid multiple versions being stored in each person's laptop? Would it be Open Refine or Google Docs where everyone can work at the same time? What is your opinion on that?
I don't have too much experience with this, but I know that GitHub is a good tool to version your data files and share your data files. It does take a little bit of getting used to if you're not used to using a scripting language or executing scripts. So it doesn't exactly have a front end, a user-friendly front end, but it certainly is a good way to version your data.
Great, thank you. Next question we have here, would you use Open Refine before you deposit data to repositories or from the beginning of a project as an alternative to Excel?
Well, my personal view is that I wouldn't really use it as an alternative to Excel. I'd certainly use it in combination with Excel and as early as possible. So it's a tool, it doesn't take the place of Excel. You want to use your spreadsheet to keep your data, but you want to use Open Refine as a cleaning tool and clean as early and often as possible, I think.
Okay, great. Just a follow-on question. This is one of my questions, actually. With regards to Open Refine, if it is, a cleaning tool, does it allow you to sort of predefine lists, for example, a set of names that you can select from a drop-down list just to, circumvent that manual typing process each time?
I'm not too sure about that, Tanya, but I think you'll find it's extremely useful, and it learns what you're trying to do as you do it. And I think you probably won't need those predefined lists. I'm just guessing, but it certainly is very convenient and efficient.
Oh, that's perfect. Thanks so much. I do have another question myself, if that's fine. So when you implement new data standards, do you typically revisit and update the older collections as well? Or do you just apply the newer standards to the newer data as it comes in?
Yeah, I think the idea is to apply your data standards to all the data that you have, not only the newest data.
Okay, great. There is a hand from Mohammed. Can we take the question?
Mohammed, you just need to unmute yourself to ask your question, please.
Okay, I'm not hearing anything coming through. So if there is an issue with audio, maybe Mohammed could type his question up in the Q&A, and then yeah, I mean, we can just pass that on to the presenter after the session. So if there's nobody else, I think we were going to have a poll soon. There we go. Poll just popped up. So if we can all just take a moment to just complete the poll. Willem, thank you. We will see you in a couple of minutes for your presentation. Thank you for standing in and responding to those questions. Yeah. Great. Okay, so while we do have some extra time, having a look at the poll results, we see that most people, 73% of us, are storing our video samples or images on portable hard drives. Next up, we have cloud storage systems. That's 24% of the participants. network attached to storage systems, and then very closely also 16% saying not applicable. Do you have a backup system for your data security? Very, very important, guys. And I'm glad to see 67% of you have said yes. 29% said no, 4% not applicable. Do you discard your videos once you have extracted the data? And 69% said no. 12% said yes, and 18% said this was not applicable to them. How do you manage your biodiversity data collected? 71% of us said that spreadsheet somewhere on my computer. 24% said a centralized database, and 4% are using web-based databases. Good. Have you visited the Global Archive online data repository? Most of us, 78% of us said no to that. 12% said yes, and 10% said that I have now. That's definitely one that I would like to go and visit soon. So yeah, thank you for participating in that poll. Did I get all those questions? I did. Great. So our next speaker is, sorry. So our next speaker is Willem Coetzee. He's a biodiversity information manager at SIA. He's a natural scientist by training who developed a secondary interest in GIS, particularly database development. He has experience in developing databases for natural science collections and biodiversity biomaterial banks. Currently, he manages biodiversity data, including the data from marine biodiversity surveys, and that is still as well as video imagery. He is part of a team that have developed a workflow for data management, focusing on the barriers and challenges, the knowledge required, and the opportunities to reuse existing platforms and software. So with that, I welcome Willem's presentation.
Hi, I'm going to talk about ways of managing images and data obtained from various aquatic biodiversity surveys. This is work that I have done in collaboration with a few colleagues who will be mentioned throughout the talk. An introduction to the South African Institute for Aquatic Biodiversity and its research platforms. I've just mentioned a few here. Firstly, we have the African Coelacanth Ecosystem Program, which I think is quite well known. There is one called the Acoustic Tracking Array Platform, which monitors the movement of fish and other aquatic organisms using acoustic telemetry. Then the Marine Remote Imagery Platform, which I'll be talking mostly about during this session. And there are various vessels and instruments, for example, a remotely operated vehicle, and obviously smaller equipment such as remote underwater cameras. Here are a few images. On the left, you can see the team deploying a stereo BRUV instrument. And on the right, you see more detail of that at the top. And at the bottom, you can see a still that has been obtained from a video from the BRUV instrument. This is the work of Dr. Anthony Bernard. The other kind of survey that I'll be talking about in detail is this, which is the marine macrobenthos work that was done by Dr. Elodie Haynes-Veal. And here you can see some spectacular images taken from those surveys. Before we start talking about the management of data and images, we need to get an idea of what kinds of data and images we're working with. And here I've just put together a small table that shows you the different surveys and their associated files. In the first row, the StereoBrov survey, that generates video and JPEG still images. And the metadata, which is what we're mostly interested in, is contained within a file called an emobs file. It's generated by an application called Event Measure. We also have a number of calibration files, which we need to archive. In the second row, we have the marine macrobenthos survey, and that generates only still images. And the application used in this case is CPCE. And then finally, the ROV survey again generates videos. And in this case, we have a number of dive log files or calibration files. So this is the range of files and data that are generated, and we need to consider which files will be archived and how we are going to store them in the data management system. Before I became involved in managing biodiversity imagery, I was mostly doing data management in the context of specimen collections in a natural history museum. And for this, I was using Specify software, the Specify software suite of tools or applications. And it occurred to me that it would be a good idea to see if I could reuse the Specify software in the context of the biodiversity surveys that we are discussing. And my thinking there was that biodiversity occurrences and events occur whether we are talking about a natural history museum or not. So whether we are talking about actually collecting a physical specimen or making an image of biodiversity, the same occurrences and events would be important in the data. So that is an interesting theoretical question that can be explored from various angles and written about. And it's something that I am very interested in and like to work on. Then there are various applications that are very useful in the Specify suite. One of them is the Workbench application. This allows you to import data from a spreadsheet and map the columns in the spreadsheet to fields in the database tables and then import your spreadsheet into the database. The schema mapper and data exporter work together to allow you firstly to map your fields in the database to, for example, a standard such as the Darwin core, and then the data exporter exports your data in standardized form, and that allows you to then publish your data, for example, on GBIF. So these are the software tools that I used, and at the end of the presentation I have a few slides that show you some detail about the upcoming release of the new version of Specify 6 and 7. And there are some links in that slide that take you to more detailed information and a demonstration database which you can try out for yourself. And so if you're interested in using Specify software, I would encourage you to read that information and try the demo out and get involved with Specify and talking to the Specify people in Kansas. It's, I think, a very powerful system, especially for natural history, but as I say, it's not limited, it shouldn't be limited to natural history. I'm also using Specify in the context of a biobank of biomaterials that we keep in freezers. And so I think that Specify software is extremely versatile. Not only can it be used to document natural history specimens in minute detail, but I think it can be used in various other contexts. And this is perhaps the most important message that I would like to convey, is that there are tools out there that can be used for different, for various purposes in data management, biodiversity data management. And I have found that this one is extremely useful. This is just a mock-up of a section of the specified database schema. I just did this in Access. I was trying to develop an Access database that would simulate the specified database schema, just for training purposes, and to develop my own Access skills. And so I've just shown this as a way to familiarize you with some of the tables in the specified schema. The most important tables are what we call the collection object table, and this can be used to represent different things depending on how you do your data modeling. In the natural history context, usually we use this to represent either an individual organism or a lot of organisms, for example, in a bottle. And that collection object is then related to collecting events, and there can be many collection objects related to one collecting event. And once again, a collecting event can be defined according to how you want to model it. From the collecting events table, we have a link to the locality table, and obviously there can be many collecting events in a locality. And then the locality is linked to what we call a geography, and this is usually a political boundary, such as a state or province or a country. Then we have other important tables, the determination table and the taxon table, and these are important for documenting identifications to species or higher level of the taxon tree. And then I've just shown other tables like the collector table and the agent table. An agent is a person or institute, and that person can be not only a collector but also a determiner or an author, etc. So this slide is mainly just to show you, to introduce you to the basics of relational database management, if this is something that you need. And we can talk for years about the complexities of database schemas, and specifically the specified database schema, which is extremely complex and elaborate and completely represents what we need to represent in biodiversity data management. Before continuing, I would like to extract a few important points. Firstly, I have said that our data represent abstract occurrences and events or concepts, and these can be common to different contexts. And we can exploit this commonality by using the same software to manage the different data from these different contexts. Secondly, a point I haven't made explicit yet, and that is that this talk is mostly about the complexities of managing the data or metadata associated with benthic images, but I will also address file management later on. And thirdly, I've made the point that specified software is capable of representing the occurrences, events, localities, and taxa contained in our data. And further, because it is a web application, it opens the door to, for example, larger institutions hosting smaller institutions, as well as to collaborative data management or editing. Data modeling is the process of deciding how to represent abstract concepts that exist in your mind in a database, in the tables and fields of a database, and how those concepts correspond to those tables and fields. This is the first table I will show you, the collecting trip table, which I realized I actually neglected to show you in the database schema in the earlier slide. A collecting trip is typically something like an expedition or a cruise, and it consists of many collecting events. So if it is a cruise, you can think of all the stations along the cruise where the ship stopped to do a trawl or whatever as being collecting events, and all of them together constitute a cruise. Or in the case of a terrestrial expedition, a collecting trip can be constituted by various different collecting events if you stopped at different localities, but you wanted to assemble all these collecting events into a greater record. That would be an expedition. So here the collecting trip represents a sample of 60 minutes of footage taken by the BRUV instrument, and therefore all the fields in the BRUV data that are contained in the emobs file that relate to the sample will be uploaded to the collecting trip table in the specified database. So something like the sample code, which uniquely identifies the sample, the location, the country, the continent, and a whole lot of other fields like the deployment time, equipment description, bait, lights, etc. These all relate to the collecting trip or the sample. At this point, I will just briefly explain the meaning of BRUV data before I continue with how the collecting event and collection object tables are used. In the previous slide, I spoke about samples or 60-minute videos, and these 60-minute videos are eventually analyzed by a video analyst who identifies the various species observed throughout the length of the video, and also makes notes and records about the group sizes or the numbers of individual fish in each group of each species throughout the video. And the objective of this is to find what we call the max N, which is the largest group of a particular species in a 60-minute video. So when that largest group is found, each fish in that group is then measured to give the analyst the length of each fish, which is recorded in the collection object table. So the max N is recorded in the collecting event, and the length is recorded in the collection object. And so now you will realize that in the previous slide, I spoke about the collecting trip table, which is used usually to represent things like cruises and expeditions in natural history. But I have reused them and changed the purpose of all three tables to use the collecting trip table to represent an event of a very short duration, only 60 minutes. And the reason for that is that they are collecting events that are linked, many collecting events are linked to that collecting trip. So I can relate all the max N records in the sample to the sample. And likewise, I can relate all the lengths to each collecting event. So if there are 10 fish in a group, I can relate those 10 fish to one collecting event. And if I have 15 different species in a 60-minute long video, I can relate those max N records, those 15 max N records, to the video sample or collecting trip. For the next two slides, I will talk about the specify workbench, which, as I said earlier, is a way to import data from a spreadsheet into your specify database. There are a few important things to know about using the specify workbench, and the use of a spreadsheet template is one of those. To ensure consistency, it's a very good idea to use the same Excel template for your data within a given project. And that just ensures that everybody uses the same column names for the same fields, and there is no confusion. The second thing is the workbench configuration file, which is just a text file that maps your spreadsheet columns to the fields in your database. And again, it's highly recommended that you use a workbench configuration file for consistency, especially if you have more than one person importing data into the database. And the important thing to know is that the workbench is potentially quite complex and the database is quite complex. Your data are quite complex. So in order to make all of this a little bit simpler and a little bit more consistent, or at least to make it totally consistent, you need to use these templates, in other words, the workbench spreadsheet template and the workbench configuration file, to ensure that consistency. Once you have imported your data from your spreadsheet and the workbench configuration file has read your spreadsheet and mapped it to map the columns to the different fields in the database, this is what you will see in the workbench, and this is the dataset mapping editor. On the left, you can see a list of tables in Specify. That column is called data types. So you have accession, agent, collecting event, attribute, collecting information, etc. And there you will see the collecting trip is highlighted. Then the next column, the second column, is a list of fields in that highlighted, that selected table. And the green check marks show you which fields have been mapped to columns in the spreadsheet. And those columns are shown in the third column, the right-hand side of this dataset mapping editor. And you will see that the specify field is mapped to the dataset column. So you've got sample date mapping to sample date, field trip code mapping to field trip code, etc. And in this case, my workbench configuration file has not managed to map all my dataset columns, and that is where you see to be discarded. So those still need to be mapped manually, or alternatively, the workbench configuration file needs to be improved slightly so that all those fields are mapped automatically. But even if that is not the case, it's easy enough to just map them manually to select a field or at least a dataset column, and then its appropriate table and field in Specify. At this point, I'd like to show you what the data look like in the Specify 7 web application. This is what a sample record looks like in the Specify 7 web application. Here you can see the sample code, and you can see that there are 10 max n records linked to this sample. In this case, the caption reads sample species, but that can easily be changed to read max n. Here I have displayed one of those max n records, and you can see the max n value displayed here. And you can see that there is one length that is linked to this max n record. And this is the length record, and you can see the length displayed here. Now I think it's time to have an overview of the whole data management process. This is the whole data management procedure. We start at number 1 at the bottom left, and this is where we simply create records manually to represent each field trip in the data set, and usually this is only one record to represent a field trip that happened in the recent past. Step 2 is where we are using the original spreadsheet exported from the event measure application and contained in the emobs file, and we try to improve the data values in the spreadsheet. Step 3 is to then import that spreadsheet into a Microsoft Access file. And I haven't spoken about this before, but the objective of this is to clean the data and to ensure that the data values are entirely consistent across the whole data set. We then make a table in that Access file, which then gets exported as an Excel spreadsheet or a TXT file or CSV file, depending on which platform, whether it's Specify 6, which is the previous desktop version of the application, or Specify 7, which is the web version. The Specify 6 version uses an Excel spreadsheet for the workbench, and the Specify 7 version uses a text file, either TXT or CSV. That file that then gets imported into the Specify workbench, and this is where the real data validation, according to the Specify business rules, happens, where it checks for incorrectly formatted values for the appropriate data types, whether they're decimal numbers or integers or text. And once the data set has been validated, it can be uploaded into the database. A very important point is that researchers are used to manipulating their data in ways that they have developed and are accustomed to. And so it's very important to give them a tool that they can use that replicates that functionality as much as possible. And this is not always possible using a custom application. And in the case of Specify, it was thought that the users might find it slightly convoluted. And so I developed this front end in Microsoft Access, and it connects to the MySQL database and displays various tabs. At the top, you can see the user can select which tabs he or she wants to see and can apply filters on various fields and can also export the data from each of those tabs. So this is a very simple way to query the data and to export the data to send to somebody, just to do particular small analyses on particular subsets of the data. I said I would talk about the manipulation of the image files themselves, and Specify does allow you to attach digital files, including images, to many or most of the, if not all of the data tables. So for example, you can attach to the collection object table, the collecting event table, the collecting trip table, etc. And many of the files that we use in the course of the Benthic Imagery work will be attached to the collecting trip table. For example, the macrobenthos images and the videos, the BRAV videos, get attached to the collecting trip table. And there are also sophisticated routines in Specify for importing batches of images. And so image management is perhaps not the main objective of Specify software, but it certainly accommodates routines that allow you to manipulate images. And there is a degree of automation as well. So this is what it looks like. Attach an image to a collecting trip record. And this is one of those macrobenthos images of Dr. Elodie Haynes-Veal. Now I'm going to talk a bit about data publication. The South African Institute for Aquatic Biodiversity publishes a large volume of biodiversity data through the GBIF data portal. And we do this under the Creative Commons attribution license, which means that as long as the data source is acknowledged, the user can use the data in fairly unrestricted ways. A screenshot of a sample record in the GBIF data portal, a sample of the BRAV data, and you can see a link to the field trip there, and a link to the max-in records of the various species, which are called occurrences in the Darwin core vocabulary. And if I click on those 20 occurrences, I get the list of max-in records. we have published the BRAV data as well as the macrobenthos data, and here I've just put the links in for you to use if you want to have a look at how those data sets appear on the GBIF data portal. And then lastly, I said that I would include some information about release of Specify 7 and the new workbench, and you can find that here. And then finally, I want to say thank you to everyone who assisted me, and Roxanne Juby, Dr. Anthony Bernard, Dr. Elodie Haynes-Veal, and Dr. Taryn Murray, as well as the Specify team in Kansas for advice, technical support, and assistance over many years. Thank you.
Great, thank you, Willem, for that presentation. Very, very interesting indeed. I am looking at the Q&A and I don't see any questions yet, so we'll just give participants a second to provide us with their questions. Alternatively, participants, if you want to raise your hand to ask a question, you may also feel free to do so now. While we are doing that, while we are waiting, I've got some of my own questions, if we don't mind. The Specify user form that you showed, is that open to the public? Or how would people be able to access that type of information?
Okay, that was in our SciApp database, so you would need a username and password for that particular database to have access. And they are developing the security of Specify, and it is a concern, you know, being a web database. Yeah. But this is under continuous development, and I think in the new version, the security is pretty well developed.
Okay. Maybe this is an opportunistic question, but do you foresee the Specify software being web-based, able to provide a metadata extract or so in the future for users if they, maybe input a search query or so, and it can pop out all the records that hold that type of search word?
Yeah, certainly. That is the idea, although one wouldn't really want to interact directly with the data repository. And so I think ideally one would want to publish your data timelessly so that data are always current, and you can use the GBIF repository to rather run your query. But I guess there are different ways of doing it, and it just depends on your capacity to first of all, to populate the database, and then secondly, to publish the data. Those are both bottlenecks that are going to result in various data possibly not being available. And it depends on how efficiently you can unclog those bottlenecks as to whether you're going to be successful in your query or not in a particular place. But this is all work in progress, and we're trying to improve.
Yeah, I think we're all trying to improve in this thing. I think data management is quite something that has popped up in a lot of our lives, and we're all just trying to play catch up in that. So with that, your data management within your organization, are you the only person that captures the data for everyone else, or how would you manage? How is data actually managed? Is everybody responsible for inputting their own information into the system?
Yeah, that's an excellent question, and that's always the devil is in the detail, because one can have fancy schemas on a screen, but translating it into practice is always difficult. But no, the person who captures the metadata from the source videos is the video analyst, who's trained in identifying the necessary species. That spreadsheet is then sent to me, and I import it into the Specify database. So it is definitely a collaborative team effort. I haven't even actually addressed the different versions of the data. If any mistakes are found or areas that need improvement, a new version needs to be produced. And so you certainly can't do that with only one person managing data. It needs to be at least 3 or more people in a team. That's how you constitute that team, and how the team works together to be efficient is always going to be a difficult thing to do.
No, for sure. Thank you for that. I've got one more question from my side. You mentioned that obviously you publish your data sets. So when you do publish, do you apply for DOIs on all of your data? Or is it just specific data sets that you would apply for a DOI prior to publishing?
This is not something that I'm terribly clued up on, Lauren, sorry.
Okay.
A DOI does get assigned to various levels of your data by GBIF automatically. But I think not necessarily to every single occurrence record, but I stand to be corrected on that.
Okay, great. Oh, I see we do have one in the Q&A. Who owns the copyright of the videos or pictures?
I'm not really qualified to answer that. Perhaps somebody else who's listening from SciAP can answer more fully.
So I think the copyright remains with the videos and pictures. The copyright would remain with the person who collected the data, or the person who paid for the data to be collected. Yeah, so that would be that.
Great, thanks Anthony for assisting there. We do have one question, which I think is a much more general question, that the slides were not always clear. Is it possible to please include some references and links to the extra info in a separate document for circulation to the participants? So that's more of an administrative question, I think. Sure. Okay, and with that, I don't see any other further questions. We are basically on time. Willem, thanks so much again for your wonderful presentation. And yeah, thank you. And I just want to say a big thank you to all the other presenters who also presented during the session. It was quite informative. I really enjoyed it, since I really enjoy the data management aspects. So there have been links posted in the chat for tomorrow's session. So it's just a reminder that it's in a different Zoom venue. And I think that the email has been sent with the link to the venue for tomorrow's session. Yeah, so just looking at the looking back at the presentations that were delivered during the session, I've made some points here on just some key points that I thought were important. So I'll start from the top. Institutions must have resources to manage and preserve their collections. That was specific to Robin's presentation. Communication and coordination between institutions are important to prevent duplication and to capture all the relevant fields, everything necessary. We see the value of electronic databases. All of our presenters had mentioned electronic databases in their presentations, and also that open and freely accessible information is quite valuable to the public. It's important to manage your data yourself, as nobody understands your data the way you do. So I think taking ownership is something that we promote, and definitely a very big take-home message here. Take ownership of your data, keep it clean, keep it tidy. Okay, it's critical to back up your data. We can't predict things like hardware crashes or loss or theft or anything like that. So always have a backup that we can fall on, and make sure your backup is, not located next to your laptops that might fall in the ocean or so. Okay. Data sharing is very important in research because everyone benefits from it. Data quality should be assigned as close to the collection or creation point as possible, because the cost of not doing data management can be extremely high. And then finally, existing tools can be reused and repurposed in data management. Yeah, so those are just my few take-home points from all the presentations we had today. And yeah, I think we are a little bit ahead of schedule, but this does bring us to the end of today's workshop. We hope you enjoyed it. We found it very informative, and we look forward to seeing you tomorrow for the final day. Thanks very much, everybody. Have a lovely day further. Thanks. Bye.